Hello friends. In continuation to our previous videos, today we shall be discussing about another important equipment from petrochemical sector, the fractional distillation column. We will also learn about their working process, internals, and their maintenance procedure. So let us proceed ahead. Fractionating columns, also known as fractional distillation columns, are essential equipment in oil refineries used to separate crude oil into its component parts or fractions based on differences in boiling points. The process is called fractional distillation and is the first and most important step in refining crude oil. Let us see how a fractionating column works in a refinery. Heating. Crude oil is heated, often with high-pressure steam, to about 600 degrees Celsius 1112 degrees Fahrenheit to vaporize it. Vapor entry. The vaporized crude oil enters the bottom of the tall vertical fractionating column, which can be 6 to 60 meters tall and 0.5 to 6 meters in diameter depending on the refinery. Rising vapor. As the vapor rises through trays or packing materials inside the column, it cools gradually due to a temperature gradient, hot at the bottom, cooler at the top. Condensation. Different hydrocarbons condense back into liquids at different heights where the temperature matches their boiling points. Heavier fractions with higher boiling points condense near the bottom, while lighter fractions condense near the top. Collection. The column has multiple draw-off points at various heights to collect these liquid fractions, such as gasoline, kerosene, diesel, lubricating oils, and gases. Further processing. Most fractions require additional chemical processing to improve quality or convert into more valuable products like gasoline. The following fractions are obtained via distillation process, namely gases. Lightest fractions like propane and butane collected at the top. Light distillates. Gasoline, naphtha, kerosene, jet fuel with boiling points around 70 to 200 degrees Celsius. Medium distillates. Diesel and gas oils with boiling points 200 to 350 degrees Celsius. Heavy distillates. Fuel oils, lubricating oils, and greases with boiling points above 350 degrees Celsius. Residues. Heavy tars and bitumen at the bottom, often further distilled by vacuum or steam distillation. Fractionating columns enable the efficient separation of crude oil into useful products by exploiting the differences in volatility of hydrocarbons. Their design with trays or packing maximizes vapor-liquid contact, improving separation quality. This process maximizes the yield of valuable fuels and industrial products while allowing refineries to meet market demands. What is the role of trays and packing materials in fractionating columns? Trays and packing materials are critical internal components of fractionating columns, each serving to maximize contact between rising vapors and descending liquids, which is essential for efficient separation of mixtures by distillation. Trays. Trays are horizontal plates installed at intervals inside the column. They contain holes or perforations that allow vapor to pass upward while liquid flows across the tray surface. The primary function of trays is to promote intimate contact between the vapor and liquid phases, facilitating mass transfer and thus the separation of different components. Each tray acts as a stage where vapor and liquid can reach equilibrium. The more trays present, the greater the potential for effective separation, as each tray provides an opportunity for partial condensation and vaporization. Tray design, such as sieve, bubble cap, or valve trays, and spacing influence efficiency and performance. Packing materials. Packing materials are used instead of trays in some columns. They fill a section of the column and provide a large surface area for vapor and liquid to interact. Packing can be random, like Rashig rings or glass beads, or structured, arranged in a specific pattern, both designed to enhance surface area and mass transfer. Liquids with the surface of the packing while vapors flow over and through it, allowing mass transfer to occur across the wetted surfaces. Packed columns often offer lower pressure drops than tray columns, making them suitable for vacuum operations or when handling temperature-sensitive or corrosive materials. The maintenance procedure for a fractionating, distillation, column during shutdown in a refinery, involves a systematic sequence of pre-shutdown, shutdown, and post-shutdown activities aimed at cleaning, inspecting, repairing, and restoring the column to ensure safety, efficiency, and operational reliability. Pre-shutdown activities. Identify and tag the equipment to be maintained and worked upon. Erect scaffolding for safe access to the required locations at different elevations. Remove insulation from blind locations and manways for ease of access. Apply derusting solvents to bolts and perform hot bolting to ease future dismantling. Arrange necessary blinds, gaskets, tools, exhaust fans or air movers, 24V lighting, and rope pulley systems for main shutdown works. Prepare for safe opening by planning and undertaking adequate safety measures. Shutdown activities. Obtain work permits and perform blinding of the column as per the blind list to isolate sections safely. Open all manways and install air movers and lighting to ensure ventilation and visibility for the working crew. Conduct gas testing and obtain confined space entry permits. Perform initial internal inspection through manways. Open tray manways and erect internal scaffolding if needed for access. Carry out pre-cleaning inspection to assess fouling and damage of any section. Perform manual cleaning or high-pressure cleaning of internals as required, typically cleaning from top to bottom and covering nozzles at the bottom to avoid damage. After cleaning and vacuuming out dirt, conduct an acceptance inspection. Perform detailed internal inspections using visual testing, VT, penetrant testing, PT, and ultrasonic testing, UT, to detect cracks, corrosion, or defects if any. Buff weld joints and carry out necessary repairs based on inspection findings. Final inspection by operations, reliability, and process teams is performed to approve readiness for box up. Box up trays and manways carefully, usually from bottom to top. Remove temporary lighting and air movers from the equipment before final box up. Deblind and reinstall connections, by torquing bolts in the correct sequence to ensure leak-proof integrity. In post-shutdown activities. All blinds from the column are removed. Insulation is refixed to the sections from where it was removed. Dismantle the scaffolding and perform housekeeping. Monitor column performance upon restart to confirm restoration of efficiency and safety. Few key points are to be kept in consideration. Cleaning and inspection restores separation efficiency by removing fouling and detecting damage. Safety is ensured by proper blinding, gas testing, and confined space procedures. Repairs and weld buffing address corrosion and mechanical wear. Proper torquing and sealing prevent leaks and structural weaknesses. The entire process minimizes unplanned downtime and extends the column's service life. This structured maintenance approach ensures that fractionating columns operate safely and efficiently after shutdowns, supporting continuous refinery operations. Towards last, I would like to thank you for your time and patience. Kindly do share your experience with the industry practices in the comments section. We will be back with other informative videos in the near future. Have a great day ahead.